Good afternoon, everyone. Can you hear me?
Yes.
Okay, great. Today is September 1st. It's Tuesday, and we're going to begin chapter 8. I am recording the session, so make sure you're able to go back and listen to the recordings. Does everyone know where to access these recordings on Blackboard? Great, good. So that's one of the beauty of these online sessions, right? That you can actually go back and listen to it if you didn't get something during the classroom lecture. Here's your opportunity to go back, take notes, refer to it when you're doing the homework. So all these recordings are available on Blackboard. Okay, so what you're looking at in front of you is the solution to that last problem that we did in class. I also emailed you these solutions. If you didn't receive an email from me, let me know and I can send this to you. Speaking of the last class, I have to mention a few things. First, we go to my notes here. So in the last class, we had polls um, that I conducted during lecture. Now, I mentioned that these polls are not counted towards your grade. It just tells me that you're participating, you're engaging. So it doesn't matter if you get the answer wrong when I have these multiple choice questions posted during lecture. It just tells me that you understand something, or maybe I didn't explain a certain topic. I have to go back and explain it. So again, the polling that we have during lecture is just indicating participation. Now, by some chance, if you don't have good Wi-Fi or you have technical difficulties and you don't have enough time to complete the poll and submit your answer, you will not be penalized. Just let me know by the end of the day, and then I will have a note when I'm incorporating participation into your grade. I also get a report at the end of each session letting me know who attended, so I have your name with that. The other thing we did in the last class was breakout sessions. Now, the breakout sessions are temporary. If you didn't have enough time to exchange information or discuss what I posted, that's fine. I didn't give you enough time. That was my fault. But in the future, when I do breakout sessions, understand that this is just temporary. You don't have to continue with the same breakout session for the rest of the semester. What I will be doing in the near future, so that could be next week or the week after, is I will formally place you in groups. So when I do that, that's something that I will assign you to. You do not choose your own groups. The reason is for you to work on your Excel assignments. So these teams or groups are there for you to study together, to exchange information, your contact information. Um, you can do the homework together, and most importantly, you have to do the Excel assignments together. So that's going to happen in the near future. So if I happen to do in breakout groups during lectures, don't worry about exchanging contact information. You might not have enough time for that. And I see that there are some questions here for me. So I see that some of you did not receive an email. Okay, so the reason you didn't receive an email is because I only email through MyLab. So remember, if today is your first class or if Thursday was your first class, right after class, the first thing you should do is register for MyLab. And how do you do that? The instructions are on the last page of the syllabus. You enter through Blackboard and click on My Lab, and that will take you directly to this site which is run by Pearson, the publishing company, and you don't need an access code. It takes you directly to the course MyLab. So once you register, if you've never used My Econ Lab, My Finance Lab, you have to create an account. If you have used My Econ Lab, My Finance Lab, then use your same username and password. So when you log in, you're immediately taken to this course. You do not need an access code. You can have access to the e-textbook and all the homework that is associated with this course. So remember, you have to do that immediately because your first set of homework is due this Sunday, September 6th. Sorry, September 6th. So that brings me to the next slide because I have to talk about accessing MyLab. Okay, so that is this. So what you're looking at is once you enter MyLab, this is how your main page will look like. Now remember, when you register for MyLab, make sure you use an email address that you check often because that's the email address I'm going to be emailing you. So on this main page, you will see announcements that I post. And for you to access homework, so I'm going to write on this slide so you see it here. When you click on assignments, you will see a list of all the assignments that are available to you. Now, when you move on to September, so right now you're looking at the August calendar. When you move on to September, you will see that there are 3 assignments due for September 6th, this Sunday. So you have chapter 1 homework, which we completed last week on Thursday. Today I will do chapter 8. So you will have chapter 8 homework. And then this Thursday I will do chapter 2. So you will have chapter 2 homework. So all that is due on Sunday, September 6th. Now I mentioned in the last class that you have 3 attempts to do your homework, every question in the homework. So make sure you do a little at a time, save it, come back to it. Don't start all your homework on Sunday afternoon. It's too much. You have the whole week, right? So do a little at a time. So that's where you would access assignments. And now where would you access all the PowerPoint slides and the syllabus? Well, if you click on course tools over here and then select document sharing. Okay, so click on course tools, then document sharing. You will be able to see all the PowerPoint slides that I post. So you should be able to see chapter 1 and chapter 8 so far. Any questions for me before I continue? So that sort of answers why you didn't receive an email from me, right? So if you haven't registered for MyLab, then do that immediately after class today. What else did I want to show you? When you're doing the homework, this is an example of the homework, one of the questions in assignment number 8. So when you're doing the homework, and let's say you're stuck on a problem, you're not sure how to do it. Now remember, you have 3 attempts to do each question. Most questions, I'm going to say, have 3 attempts. Some questions have 2 attempts. It depends on whether it's a calculation problem or a definition, so it's not always 3 attempts. If you have a question about the homework that you're working on, if you select question help over here, you will have these help aids, which is a drop-down box that you're looking at. So if you click on ask my instructor when you're working on a question, what it does is it sends me an email automatically, and you can type in that email saying, right now I'm working on question number 5 of assignment 8, and I don't understand this. So Professor Vitanachi, can you please help me solve this problem? So I get that email directly and I can answer that question. If you click on help me solve this, it gives you some hints as to the process of solving the question. Okay, it doesn't give you the answer and it doesn't give you an example, but it leads you through the step-by-step process of solving it. If you select view an example, you will get a different example of the same exact problem, but with different numbers if it's a numerical calculation. So again, just to help another help aid to help you solve this problem. Now the thing is, if you use any of these help aids, those 3 attempts, you won't be able to use the 3 attempts. So meaning, if you select view an example, that means you've lost 1 attempt. So now you have only 2 attempts left. If you select ask my instructor as well, now you've lost 2 attempts. Okay, so sometimes it's fine, you just don't know how to solve the problem and you need to use the help aid, which is fine. But yes, I will only use the highest attempt score, this highest score of all those 3 attempts. And if you get the question wrong all 3 times, then you get it wrong. You know, there's nothing I can do for that. So going back to the question, Yazan, you said on September 6th, you will have 3 homeworks that are due. Chapter 1 from last Thursday. Today's homework will be Chapter 8. And then Thursday's homework, which is Chapter 2. So 3 homeworks. Okay. Some of you are saying that there's some background noise that you're hearing. If everyone can mute their microphone and just have my microphone on, I think it should be fine. You do not need a course ID. As long as you go through Blackboard, you're able to click on My Lab and immediately register. Okay, so if you're having problems registering for My Lab, send me an email separately and then I will try to help you. I hear that you're still having some issues with background noise on my side. Anyone else having problems with my microphone? Okay, let me do a quick check to make sure everyone has a microphone off. Okay, I think there's someone on a phone, and that's the person that has, okay, it should be fine now because it should be muted, and I'm the only one speaking. Hopefully that should be better. Okay. So I'm just going to continue.
It's still not clear, Professor. We still hear whatever is going on in your place. Do you have a window open? Is there a draft or something?
Yeah, it could be that. So hold on, let me see if I can fix that.
That's a lot better.
Okay, so that's the best I can do. Is that a little better? Okay, good. So I'm going to move on to this next bit of information. So this is an example of an announcement or an email that I will send out about events that are happening on campus. So this is from the Career Center. They're having an info session tomorrow, which is Wednesday, September 2nd, from 12:30 to 1:15. If you don't get a chance to look at this meeting ID and link, I will email it out to you through my lab, and also post an announcement. So what it is Amazon is hiring and they're recruiting even during these times. So this is a great opportunity if you're interested in operations. So Amazon is hiring. I know that they opened an office in Manhattan, even though they didn't open the headquarters in Long Island City. There's a new office opening in Manhattan. I believe it's an internship. So I'm not sure what exactly it is. I think best is go for the info session, get to know who it is. If you could get a contact information, email them. All right. So moving on to the next thing. So I'm going to do a poll just to refresh our memory about the things that we talked about in the last class. So before I start our new chapter 8, I'm going to type in my question here. Okay, so you should be able to see it. Okay, I'll give you another minute to answer this. Okay, and I'm going to stop the survey, so make sure you put in your response, and then let's discuss. Okay, so you can see here that most of you chose participants, and participants is actually incorrect. Does anyone want to explain to me why participants would be incorrect? So why would participants be incorrect? Anissa, you're saying because it considers people in an experiment. Jeffrey say participants account for people in an experiment. You says it's people in an experiment. So actually, the three of you are right, and everyone who responded with number 3 is correct. So the answer is respondents. Subjects and participants are the same thing. Subjects and participants are people who participate in an experiment. People who respond to a survey are called respondents. Units are inanimate objects like animals, plants, items that you're considering. So again, the answer is respondents. Subjects and participants are those who participate in an experiment. Okay, so I didn't spend much time in the last class with certain definitions. I sort of went very quickly. But in your homework, you will have questions that are very specific like this. And what I need you to do is read the textbook. So the textbook has these definitions explicitly. I might not have enough time in the class to go through each one in detail, so make sure you do that. Rad, you have a question?
Yes, Professor. Thanks for taking my question. I finished homework number 1, and I just have a question regarding the survey. So the one of the question was if the it was regarding a poll or a survey, I think. So I just wanted to go over the difference between poll, experiment, and survey, please.
Between poll, experiment, and survey. Okay, so the individuals who respond to a survey are called respondents. The individuals who are included in an experiment would be participants or subjects. So now a poll is slightly different, and I will talk about that in this new chapter that we're going to do. But with a poll, it's people who voluntarily respond. So like we're doing today, I have a poll that you're voluntarily responding, and I will get back to that and what that means in chapter 8. But as long as you understand the difference between experiment and survey, meaning subject participant and respondents. Got it?
Got it. Okay, thank you.
Okay. So now I have one more poll question, and we'll do that really quickly. Typing it up, and now I'm posting it, so you should be able to see it. So I'll give you another minute to answer that question. Okay, and I'm stopping the poll. So you can see here, most of you answered true, and true is correct. That's right. It's because we have regular intervals every quarter for only one variable. We're interested in the profits for that company. So yes, I'm not going to talk more about this. I see that you get it, so I'm moving on. So again, if you missed the beginning, I said that I will be formally placing you in groups or in teams in the near future. So if you don't have contact information with anyone else, that's fine, because very soon I will be placing you in groups so that you can work on your Excel assignments together. Okay, so now I'm going to start with chapter 8. And if you have chapter 8 open in a different tab, you can follow along, or you can follow on the screen, or you could print it and have it in front of you. Okay, so in chapter 1, we talked about data, and we said that statistics is a way to get information from data. And we spent a lot of time talking about how important data is, and the different types of data, and how you can divide data into quantitative or qualitative. So now I'm going to say that if data is so important, then we should be collecting information about everyone. But the problem is, when you collect information about every single individual, it takes too much time, it's not practical, your budget might not allow it because it costs a lot, you need a lot of manpower. So instead, you can take a portion of your entire population. You can take a sample. The issue is, do you have the right sample? Are you limiting your conclusion? Is your conclusion accurate, or is it flawed, or is it biased because you're dealing with a sample? So sampling is very, very important. So chapter 8 will focus completely on surveys and sampling. So I'm going to start with the first slide, which is really the definition for inferential statistics. So this is the first type of statistics that I will discuss. There's two types. Inferential statistics is the first. Inferential statistics basically says that you take data from samples and come up with a conclusion about your population. So based on your sample, you're making a conclusion about the population. That process was inferential statistics. Okay, so making a conclusion about the population based on your sample. This method is inferential statistics. So there are three ideas of sampling. Number one is the sample itself. Number two is randomizing. And number three is the sample size. So we're going to start with the sample size. Before I start with that, I'm going to go back to the chat box because I see that there's an issue here about groups. Don't worry about the groups that I assigned in the last class. That was temporary. So when I do breakout groups during the class, those are temporary. That's not the group that you are assigned to. I will be assigning you formally to a different group. Okay, so you can disregard this issue about am I in a group or am I not in a group? Right now, nobody's in a group. Okay. To access the slides, these slides on MyLab, you would click on Course Tools and Document Sharing. Okay, so I will discuss groups again at the end of class. Now, the first idea is sample. So let's talk about the sample itself. So a couple of things here. We'd like to know about the entire collection of individuals called population, but examining is usually impractical, if not impossible. So like I said, it's not really practical to look at every single individual in the population. So the definition for this term population is the collection of things under consideration. So all things under consideration. And from now on, I'm going to denote population by this capital letter N. N stands for population. So for example, and I'm going to write on the slide now, an example of population is all Queen's College graduates from last year. That's an example of population. All Queen's College graduates from last year. All things under consideration, right? It's huge. Everything under consideration. Now, if I select a portion of my population, that's a smaller group of individuals, and that's my sample. So sample is a portion of the population. Sample is denoted by this lowercase letter n. In your homework, you might not see the word sample, you might see the word sampling frame, which refers to the same thing. Okay, so sampling frame means sample. What's the portion of the population that is selected for analysis? So if I have an example, I would say 100 Queen's College grads or graduates from last year. So that's my example, 100 Queen's College graduates from last year. So I don't need to look at the entire population. Moving on to the next slide. So still this idea of the sample itself. Now, one way of taking a sample is through a survey. So a sample survey is designed to ask questions of a small group of people in the hope of learning something about the entire population. So the whole idea is you're asking them questions so that you can learn something about the entire population. You can come up with a conclusion about the entire population. This is inferential statistics, that process. But samples that overemphasize or underemphasize some characteristic of the population are said to be biased. So you don't want a biased sample. You want a sample that represents the entire population, that reflects the entire population. Why? Because when a sample is biased, the summary characteristics of the sample differ from the corresponding characteristics of the population it's trying to represent. So at the end, you're not actually reflecting your population. So your conclusion is flawed. So in order to make the sample as representative as possible, then you have to select individuals from the sample at random. So the key is you have to randomly select items or individuals. That's the only way you can accurately reflect all the characteristics of your population. Otherwise, you're going to have misleading information. Any questions? No? Okay, so that brings us to the second idea of randomizing. Randomizing protects us by giving us a representative sample even for effects we were unaware of. So if you randomly select, then you're sure you are accurately reflecting. You're protecting from the influences of all the features of your population by making sure that on average the sample looks exactly like the rest of the population. So it's all about being fair. Now, I'm going to give you a quick example of you sampling in your day-to-day life. Let's say you want to declare economics as a major, and you've heard all kinds of things, positive and negative, you're a little unsure. So that's your conclusion. Should you or not declare econ as a major? So what you do is you decide to take a few econ classes. Now you can take all of them, that would be the population. Why? Because you don't have enough time, you want to graduate within the time period that you want. You don't have excess funds to just keep on taking classes, econ classes. So you select a few. But now you're not going to purposely select all the easy ones or the ones where you hear the professor is nice or easy or whatever reason, because that would be biased. So you randomly select a few electives of economics and of course your core requirements, and then you come up with your conclusion. So this is an idea of using inferential statistics and coming up with a conclusion. So you're sampling to make a decision about the population. Moving on to this idea of randomizing. So how well can a sample represent the population from which it was selected? So how exactly can you randomize, and how do you know you've done a randomization well? So if you look at this table here, you're looking at two samples, sample 1 and sample 2. Each sample has 8,000 individuals randomly selected from the population. Okay, so sample 1 has 8,000, sample 2 has 8,000 individuals. And if I look across each case, I see different column titles, meaning my variables. So we have age. So if I look at sample 1, the average age is 61.4 years. The percentage who are white in sample 1 are 85.12. 56.2% of individuals in sample 1 are female. The average number of children is 1.54, and so on. 71.36% said yes, they own a home. Now, if I look at sample 2, the numbers seem very similar. So that's what this statement at the bottom says. Notice how the means and proportions are similar on all 7 variables. Any questions for me?
Yeah, Professor. So you basically just take 2 samples randomly, and then when the numbers are alike, that's what makes it a good sample, a good random sample?
Exactly. So I'm saying that if I randomly select individuals for sample 1, randomly select individuals for sample 2, and I have all these values for all the different variables, and if their similar, that means I did a good job in randomly selecting. I did a good job in accurately reflecting the population. It's a good representation of the population. If I had in sample 1 a home ownership that was completely different from sample 2, that means something's not right, something is biased in the sample. I purposely selected individuals that lean towards a certain characteristic. So something's not right. So yeah. I have a question. What's the meaning? Oh, let's erase that. Why that did that? What's the meaning of means and proportion? Can someone explain it to me and give me an example from the table? Let's start with means. What does that mean?
Average.
Yep, average. So can you give me a value that you see on the table that would be an average?
Average year, like 61.
Yep, so 61.4 is the average age, which is means. What about proportion? Female. So Kevin, you say female is an example of proportion? Yes. So another word for proportion is percentage. Percentage, yeah, percentage, proportion, it's the same thing. So anytime you see the word proportion in the future, we're referring to percent. And mean means average. Yep. So, and moving on to the next slide. Okay. Yep. So this idea of randomized. If a survey is given to, skipped, let's go back. If a survey is given to multiple random samples, the sample will differ from each other and therefore so will the responses. Now we know that every time I take a sample, 8,000 individuals in one, take another sample, 8,000 individuals in the other, the responses are going to be different. They're never going to be identical. So we understand that they will be different. These sample-to-sample differences are referred to as sampling error. But understand that there's no actual error. So no error has actually occurred. It's just that these differences are called sampling error. And we will get back to this through the course when we get to other chapters. I will be referring to sampling error, but understand this is just a matter of differences in the responses when you look at the samples. And we expect that. It's normal to have sampling error. Okay, so let's move on to the third idea, which is the sample size. So I'm going to read first and then explain. The size of the sample determines what we can conclude from the data, regardless of the size of the population. So I'm saying the size of the sample is regardless of the size of the population. It doesn't matter what the size of the population is when you decide to select the size of the sample. It doesn't matter what the size of the population is. That seems a little bizarre. Hold that thought. I'm coming back to it. That being said, it should be less than 10% of the population. So when you select your sample size, the only condition is that it should be less than 10% of the population. The fraction of the population you sample doesn't matter. The sample itself is important. It should be randomly selected. That's all that is important. It doesn't matter what the size of the population is, as long as it's less than 10% of the population. Now, there is a formal method of selecting the optimal sample size when you're dealing with a certain population size, when you're dealing with amount of sampling error. So when you have all that information, all these different factors, there is a formula that you will learn towards the middle of the course that shows you how to come up with the correct sample size. But we don't even have to get to that point. At this point, I'm saying that the sample size that you select should just be less than 10% of the population. And I'll give you an example. So Priscilla, I'll go back to your question in a moment, but let me first give you an example. Does anyone know what the population of the United States is? What is the population of the United States?
324 million.
324 million, 330 million, 350 million. Yeah, I think that's about right. Let's say 350 million. Okay, so it's probably 330 million. Okay, let's go with 330 million. If my population, so that's my capital N, right? If my population is 330 million and I want to select a sample and I want to send them a survey, something to do with the election that's coming up, so a political survey. How many people should I sample? I know now that I should randomly select them because I want to reflect every characteristic of the population, every socioeconomic group, every age group, every geographic location, every education level, etc. How many people should I sample?
33
What do you
million.
think? 33 million. What else? Anything else? Half of 330 million. Okay. What else? So I know that it should be less than 10%, less than 10% of the population, okay, which is still a huge number. So I'm going to say that once I use the formula that I show you in the next few chapters coming up, the number that you're going to get to figure out what the optimal sample size is going to tell you the number of people should be less than 2,000 people. So imagine that. Less than 2,000 people need to be in my sample to accurately reflect 330 million in the US population. That number seems so small. But how is that accurate? How can less than 2,000 people in a sample, let's say 1,500, I don't know what the exact number is, let's say 1,500 people in a sample, that accurately reflects the population? Why do you think that would be correct? So it's because of randomly selecting. So again, this idea of random selection, that's why I can choose less than 2,000 people in a sample. So Judah, your question is, can a smaller sample proportionally represent a larger population? Yes, the size of the sample has nothing to do with the size of the population, as long as it's less than 10% of the population. But the size of the sample doesn't matter. As long as it's randomly selected, yes, you can have a good representation of the population. There's something else I want to mention. The Electoral College. Does anyone know how many individuals in the Electoral College? Yep, Jazib, it's 538. So I'm saying the Electoral College, I don't know why this is not working properly. The Electoral College, never mind, okay. Yes. So if the Electoral College is 538 votes, when it was initially set up, it was supposed to represent the entire population. So there is controversy right now, and you may have read up on this, where it is not accurately reflecting the entire population, because some areas are more populated and some areas people have left for various reasons. So it's less populated. So the structure of the electoral college does not accurately reflect the population. So that's why the census is very important now, because again, there's controversy with that, where they need to know whether places are more or less populated to change or not change the electoral college. And something else that's in the news is, you may have heard that DC is trying to become a state because of that argument where it is so populated. So it's not a debate that I'm putting out there for us to debate, but it's something to think about. The electoral college is like a sample where it is reflecting the population, the entire population. So is it a good representation of the population? Is it accurately reflecting all the characteristics of every election district? So again, an example of sample. Going back to some of these points, yes, 272 win for a president. Stellan, can you explain your question? I'm not sure I understand. So if I don't hear from you, I'm saying that a 1500 sample size is a good representation of the population as long as the individuals are randomly selected. Okay. So moving on to the next slide. This is the other type of statistics, descriptive statistics. So with descriptive statistics, I'm saying that all the data is used to provide descriptions of the population. So you're not basing it on a sample, but you're using all the data in your population. So you're using some numerical calculation in terms of some statistical formula, an average, a proportion, maybe you're using some graphs and tables. So you're using all the data to provide descriptions of the population. That is descriptive statistics. So a sample is not really a sample, but it includes the entire population. That's something of a census. Now, the problem with the census is that it does not always provide the best possible information. Sometimes it's difficult and impractical to complete a census. Sometimes the population that you're studying might change because the number of people might change, and taking a census can be cumbersome because there's always some sort of error. So this is the other type of statistics. But now we're going to go back to inferential. We're going to focus on sample. Now remember, the sample represents the reality, right? That's your whole goal here. The sample representing the reality. That means the sample is a model, and models use some kind of mathematics to represent reality. So I'm saying your sample represents reality. So your sample is your model. What if I use some numerical measurement in this model? That numerical measurement, or we call it key numbers, are parameters. So the numerical measurements are the parameters. A parameter used in a model for a population is called a population parameter. So I will only use two types of parameters throughout this course. Variations of mean and proportion. So these are the only two parameters we will use in this course, mean and proportion. So these, when I refer to mean and proportion, these are the numerical calculations that are describing the population. So in my previous example, I said that population could be all Queen's College graduates from last year. So an example of population parameter would be the average income of all Queen's College graduates from last year. So that means the population parameter is average income. Any questions for me? Okay, in the same way, let's look at the numerical calculation for a sample. Any summary found from the data is a statistic. Sometimes, especially when we match statistics with the parameters they estimate, we use the term sample statistic. So here the idea is, if I use a numerical calculation about the sample, that is describing a characteristic of the sample, and that is called sample statistic. So a numerical calculation about the sample to describe a characteristic of the sample, that would be sample statistic. So an example is average income of 100 Queen's College graduates from last year. So remember, sample was the 100 Queen's College graduates from last year. So my sample statistic would be the average income of these 100 graduates from last year. Okay, so these are terms that you need to know. Any questions? No questions? Okay. So moving on to the next slide, we're going to discuss the types of samples. So now we understand that this procedure of inferential statistics is very important. You're making your entire conclusion based on a sample. That's inferential statistics. So you need to know what are the different types of samples. So in your homework, when you're reading some of the questions, it will call it sampling designs or sampling methods. It's the same thing as types of samples. So there's two main types of samples, non-probability samples and probability samples. The simplest definition to distinguish the two is whether or not they are randomly selected. So non-probability samples are samples that are not randomly selected. They are chosen without regard to their probability. Probability samples are those samples that are selected randomly. Okay, so whether or not it is randomly selected is the only difference. So I'm going to start with non-probability samples. Now I spent so much time talking about how important it is to have randomly selected items in a sample. Why do you think non-probability samples even exist? Why would we have a sample that is not randomly selected?
A control.
For control, explain a little bit more.
Like if you're doing an experiment or like taking samples, you might need a control.
Okay, so without using the word control, I'm going to go to what Judah and Kevin just mentioned. You want a more specific population. You want something that gives you results. I don't want to use the word desired results, but results that reflect a certain population. So without using the word control, yes, I agree. A more targeted population, a specific population, a population with a certain characteristic. So you don't want to randomly select because let's say you only want people of a certain age group. So in that way, yes, control. I don't like to use the word control because in statistics, when we talk about control variables, it means something else. But I know that in pharmaceutical studies, control also means something else. So yes, you want a specific sample purposely with certain characteristics. So that's one reason. Let me give you another example. Let's say a survey that is posted on a website. A survey that is posted on a website. Why would that be considered a non-probability sample?
Because only certain users will go onto the website.
Yeah, you're right. Say that again.
Like only certain users that go on that website, like those are the people they want to research. So it'll
Absolutely.
be like
Certain
not random because it's specific.
Right, you don't want random. So you want a specific website because only, so I'm reading what you said here, Priscilla, only the website user would be able to answer the poll because there's a certain demographic. So yes, you're all correct. You want um, chosen participants with similar interests. You purposely want chosen participants with similar interests. There was a hand up. You can go ahead and answer. Eliyahu, did you have your hand up?
Oh yeah, she basically said my answer. It's fine.
Oh, okay, okay. And I see that you had posted a question here. Can it be manipulated?
No,
So,
like I was answering the question because you asked why is a specific website, you know?
okay, right.
Like,
So that's
target
what I was
audience.
going to get to. Right. There's positive and negative with that, right? So you
Right.
have to be very careful when you're reading a conclusion or when you're doing an analysis and coming up with a conclusion. Um, did you specifically ask those questions on that particular website so that you can get desired results, so you can get certain results? So that would be biased. That's something that could be manipulated. But uh, on the other hand, like we discussed, um, if you want those particular chosen participants with those specific interests, that's a positive reason. Okay, so moving on to probability samples. So I said that probability samples are samples that, actually, one more thing with non-probability samples, I forgot to mention. Let's say we were in the classroom on campus and I asked a question, how many of you, by a show of hands, blank, blank, blank? Okay, let's pretend in the classroom I asked a question, how many of you, by a show of hands, blank, blank, blank? So now, again, you are voluntarily responding. So these are voluntary responses, not randomly selected. So my responses that I collect are not randomly selected. That's a non-probability sample. Okay. Now moving on to probability samples. The first, so it's simple random sample, systematic sample, stratified, and cluster. Let's start with simple random sample before I move on to the next slide. So simple random sample, again, let's say we're back in the classroom and I ask all of you to write your names down on a piece of paper, fold it, and I collect it in a bowl. And I randomly select 5 names out of that bowl. That process is simple random sample. Everyone has an equal chance of being selected. I just shake up the bowl and randomly select 5 names. So that's an easy example. I have 93 students. I can simply pick 5 names. But what if I'm talking about 1,000 individuals and I need to randomly select 5? Or I have 100,000 individuals, I need to randomly select 100. That process could be a little tedious. So instead, what we can do is use technology. So Excel uses this thing called a random number generator, and it assigns a number to everyone, and I can ask Excel, randomly select 100 names from this list of 100,000 names. So Excel can do that. It assigns a random number and then randomly selects it into a simple random sample. Okay, so moving on to the next type of sample is stratified sampling. So if you look at this diagram that's shown here, it's easy to explain when you're looking at the diagram. We have this entire population, and let's say we divide the population into groups and subgroups. So the groups and subgroups, that's where the word strata comes in. Strata, groups. So how do we divide them? Maybe we use a certain characteristic, like we divide them based on age, location, gender. So all these different colors you're seeing are different strata. Okay, so you have them in different groups. And then from the groups, you randomly select a few items proportionally into a final sample. So you randomly select from these groups, and that's your sample. So that final sample, that process is a simple random sample, randomly selecting from the different strata. So you can see here that the red group is larger, so you proportionally select more from the red group. So this process is stratified sampling. A great example of stratified sampling is public opinion surveys. Public opinion surveys only use stratified sampling. Why? Because it's the best way to accurately reflect every characteristic of the population. And it doesn't always have to be age, location, gender. It could be other things based on education, uh, income, a lot of different things. Occupation. One thing I want to mention is you don't have to really memorize and study all these types of samples for the basis of your homework and exams. You just need to be able to identify the different types of samples or the sampling methods and the sampling designs. Just know the differences between simple random sample, stratified, and now the next one is cluster sampling. So multi-stage is the same thing. So cluster sampling. So what is cluster sampling? Again, let's look at the diagram. It's easy to understand. With cluster sampling, you take your entire population and just divide it into clusters. So not like stratified, which we just saw, which would have been groups and subgroups. With cluster sampling, you're just dividing it into clusters. And then you randomly select a few clusters, which would be your sample. So you randomly select 2 clusters here, and that's your sample. So again, you're not doing groups and subgroups based on any characteristic of the population. So that's the difference between cluster and stratified. An example of cluster sampling is looking at counties and election districts. So they actually use cluster sampling. Any questions for me? Okay, and then the last sampling method is systematic sampling. So with systematic sampling, there's just basically a system. You select every 10th person on an alphabetical list of employees. That's systematic sampling. So the first individual is randomly selected, and then you select every 10th person, or every 20th person, or every second person, whatever your method is. There's some kind of system. That's systematic sampling. No questions for me? Okay, so we're going to work on this next problem together. And if we were in the classroom, what I would do is I would read out this question and I would give you all a few minutes to answer it on your own in your notebooks, and then I would call on you. So I'm going to do the same thing here. I have a list of all your names. So I will read out the question and give you a few moments, and then I will call on you to answer certain things. Okay, so the example is at the bar. Researchers waited outside a bar they had randomly selected from a list of such establishments. They stopped every 10th person who came out of the bar and asked whether he or she thought drinking and driving was a serious problem. Identify the population, population parameter, sampling frame, and method. Okay, so population, just to refresh your memory, it means everything under consideration. So think about what this article, these researchers want to write about. Who do they want to write about? It's reflecting what population? So that's your answer for population. It refers to whom? The next thing is population parameter. So remember, there's only two parameters, average or percentage. A numerical calculation that describes the characteristic of your population. Sampling frame, in other words, means sample. What's actually included in the sample for this example? And then method is your sampling method. Which method did they use? Which type of sample did they use? Okay, so I'm going to start with population. And Abraham, what do you think? Who do you think is included in the population? So you can turn your microphone on or you can type it in the chat box. Abraham, who do you think is included in the population? Okay, moving. So I'm not going to say yes to that because that's an answer to a different question, Abraham. So I'm going to go with what Michael has mentioned, people old enough to drink, and what Paul has mentioned, people who drink or go to the bar who are over 21. So yes, the population includes everyone under consideration. Now I know it's a little vague in this question. It's not telling you whether this is New York State, New York City, in the United States, in a particular country. We're going to make a lot of assumptions. I'm assuming they're talking about the United States of America. So if they're interested in asking whether or not he or she thought drinking or driving was a serious problem, this is something that you would ask adults, and it reflects all adults. So let's assume people over 21. And if you want to be a little bit more specific, you could say adults who go to bars or adults who drink. Very generic, not specific. Population, everything under consideration. Or you could just say US adults, which is also correct. Okay, so the answer to population is US adults or adults who go to bars or adults who drink or bar goers. Okay, so very general. The next question is population parameter. So Abu, what do you think? What is a population parameter? So remember, it should be either average or percentage. So Dong Yang, I'm going to say no, that's not the answer. Alexander, what do you think? So after this research has been done and you go back and look at it, what do you think the population parameter would be? Aliza? Yes, Harun, I'm going to go with what you just mentioned. So that answer is correct. The percentage of adults who think drinking and driving is a serious problem. So percentage, proportion in this case, right? So let me write that down. Percentage of people who think that drinking and driving was a serious problem. Okay, this was adults, right? Questions about that? Okay, the next one is sampling frame, meaning what exactly is included in the sample. So Alicia, do you have that answer? What is included in the sample, that sampling frame?
What do you mean? Like,
so if my population includes all adults, US adults who go to bars, then according to this example, who was included in the sample?
people who drink at a bar?
At this bar, at this particular bar. Yep. So Judah, you're right. People who drink at this particular bar. Okay, so you want to take a portion of your population, and we're told that they randomly selected this bar from a list of all the bars. So these bar patrons at this particular bar would be my sampling frame, my sample. Okay, and then the method, and what do you think the method is? Which method did they use? So we have simple random sample, systematic, cluster sampling, and stratified. Anyone want to help Anne out? Yes, Trinity, Naima, you're correct. It is systematic sampling because every 10th person who came out of the bar was asked. So every 10th person, there's a system. So every 10th person, yep. So these are some of the types of questions that you would get for chapter 8. Moving on to a new example, and this is about amusement park riders. So we can do this quickly, it shouldn't take too long. So again, I'm going to read it first. An amusement park has opened a new roller coaster. It is so popular that people are waiting for up to 3 hours for a 2-minute ride. Concerned about how patrons feel about this, they survey every 10th person on the line for the roller coaster, starting from a randomly selected individual. Identify the sampling frame. Is the sample likely to be representative? So the first thing is sampling frame, to figure out what's included in the sample. Okay, so another term for sampling frame means sample, what's included in the sample. Now, before we decide what's included in the sample, let's talk about the population. What do you think the population includes?
People at the amusement park.
People at the amusement park. Yeah, I'll go with that. So all people at the amusement park, all riders at the amusement park, at this amusement park would be the population. Okay, so all people at the amusement park, all riders at the amusement park would be my population. Now to discuss the sample. So who wants to answer that question? Alicia, you have a question?
Oh no.
Okay. Let's see. Bipin, can you answer the question about sampling frame? Anyone else wants to help him?
It's the people who rode the roller coaster or who want to ride the roller coaster.
No, I'm going to go with Stellan, the first one who gave the right answer. Stellan, you say people waiting in line for the new roller coaster would be my sampling frame, because it says here that they're only asking the people, they survey the people on the line for the roller coaster. So that's included in my sample. They survey only those people, so that's my sample. Yes, we know in systematic sampling the method, but now the question is this sample a good representation of the population? And the answer is no, it is not a good representation of the population. Judah, why would I say no? Explain. What do you think? So why do you, okay, so you're saying yes, but I'm saying no. Not for that reason. Anyone wants to explain? Stellan, yeah, I'm saying it's biased. Why? Not that it's not randomly selected. They did a good job with the random selection, doing every 10th person, but the sample itself is biased. Exactly. So you answered it yourself, Judah, because it doesn't include people not on the line. So what if I like to go to amusement parks and I like this amusement park, but I don't want to stand online for 3 hours for a 2-minute ride? And they're asking people specifically on the line, how do you feel about standing in line? So obviously the answers are going to be biased because they don't mind standing in line for 3 hours for a 2-minute ride. But they're not asking me, So they're not getting a spectrum of answers, right? So for that reason, I'm going to say that this sample is not a good representation of the population, because we said the population includes all people at the amusement park. Any other questions about this? Okay, so basically I'm saying that you have to be very careful when you're asking questions. Make sure you understand the difference between non-response bias and voluntary response bias when you're doing your homework. The rest of the slides are pretty self-explanatory. So just to quickly mention, in the last class when I put you in breakout groups, those are not the groups that you're going to be in forever. It was very temporary, just for that class time. I will formally put you in groups next week. Okay? I know that some of you have other classes, so I'm going to end class here. If you have any specific questions, I can stay on for a few minutes, or you can email me. Okay? So enjoy the rest of your day.